Welcome to Science Snippets Fun Facts and Trivia. Today, we bring you, what if the Earth suddenly stopped spinning? The shocking consequences. Chapter 1. What does it mean for Earth to stop spinning? Section 1. The importance of Earth's rotation. Imagine standing on a beach, feeling the gentle breeze against your skin. You see the waves rolling in, the sun rising in the east, and the stars slowly shifting in the night sky. All of this happens because the Earth is constantly spinning. But have you ever stopped to think about how crucial this rotation is? For everything we take for granted, the Earth spins at an astonishing speed of about 1,670 kilometers per hour. 1,037 miles per hour at the equator. This rotation creates the cycle of day and night, regulates global weather patterns, and even affects the planet's shape. If the Earth were to suddenly stop, the consequences would be beyond catastrophic. But before we get into that, let's first understand why this rotation is so essential. One of the most obvious effects of Earth's rotation is the creation of day and night. As the planet turns, different parts are exposed to the sun's light, giving us a 24-hour cycle. Without this motion, half of the planet would be stuck in perpetual daylight, scorching under the sun's relentless heat, while the other half would be plunged into eternal darkness, freezing in the absence of warmth. This alone would make life incredibly difficult, if not impossible, for most species on Earth. But rotation does more than just give us alternating periods of light and darkness. It also plays a key role in driving our weather and climate systems. The spinning of the Earth interacts with the atmosphere to create what's known as the Coriolis effect. This effect influences wind patterns, ocean currents, and even the movement of storms. Without rotation, the winds that circulate heat and moisture around the globe would collapse. Massive weather disruptions would follow, leading to extreme and unlivable conditions. The Earth's rotation is also responsible for the planet's slightly flattened shape. Centrifugal force causes the equator to bulge outward slightly, making the Earth an oblate spheroid rather than a perfect sphere. If rotation were to stop suddenly, this bulging effect would disappear, and the redistribution of mass could trigger violent geological events, including massive earthquakes and shifting landmasses. Beyond the physical and environmental effects, Earth's rotation also plays a fundamental role in the way we measure time. The concept of a 24-hour day is directly tied to our planet's movement. If Earth were to stop spinning, we would need to redefine time itself, as the sun would no longer rise and set in the way we are accustomed to. The very fabric of human civilization, from agriculture to technology, is built around the predictable cycles of the planet's motion. So, what would happen if all of this were to suddenly change? How would life, the environment, and even the laws of physics react to an Earth that no longer spins? In the next section, we'll explore the immediate and devastating consequences of a sudden stop in Earth's rotation. Section 2. The scenario of a sudden stop. Imagine waking up one morning, and everything seems normal. The sun is rising, the air is calm, and the world feels just as it did yesterday. But then, in an instant, everything changes. The Earth, our massive, spinning home, suddenly stops rotating. No warning, no gradual slowing, just an immediate and absolute halt. What happens next is beyond anything humanity has ever witnessed. At this very moment, you are moving at an incredible speed, even though you don't feel it. At the equator, the Earth's surface is traveling at approximately 1,670 kilometers per hour, 1,037 miles per hour due to its rotation. This motion has been constant for billions of years, shaping everything from our weather to our sense of time. But if that motion were to suddenly cease, everything on the planet would continue moving forward at the same speed due to inertia. The result? Utter devastation. Buildings, vehicles, and people would be flung eastward at supersonic speeds. The sheer force of the impact would level entire cities in an instant. Imagine skyscrapers collapsing as their foundations rip apart, cars tumbling through the air like missiles, and forests being uprooted. As if struck by an invisible explosion, anything not deeply anchored into the Earth's crust would be thrown into chaos. But it doesn't stop there. The atmosphere, which has also been moving with the Earth's rotation, would suddenly become an unstoppable force. Massive, unrelenting winds, stronger than any hurricane ever recorded, would tear across the planet. These winds would reach speeds matching the former rotation of the Earth, meaning that at the equator, they could exceed 1,600 kilometers per hour, 1,000 miles per hour. Entire landscapes would be reshaped in mere moments, as structures are obliterated and oceans are violently displaced. Speaking of oceans, their inertia would trigger an even greater catastrophe. Imagine billions of tons of water surging across continents in the form of tsunamis hundreds of meters high. Coastal cities would be completely wiped off the map. Rivers would reverse course, and lakes would overflow, leading to widespread flooding. No place on Earth would be safe from the sheer force of moving water. Meanwhile, deep underground, the sudden halt would send shockwaves through the Earth's crust. The tectonic plates, which usually drift at a slow and steady pace, would experience an unprecedented jolt. This would trigger some of the most powerful earthquakes in history, causing entire landmasses to shift. Dormant volcanoes could be awakened, spewing ash and lava into an already collapsing world. In just a matter of seconds, the familiar Earth we know would be gone. Civilization would be reduced to rubble, and the planet itself would enter a new and terrifying phase. But the destruction wouldn't end there. As the days and months pass, the long-term effects of the Earth's sudden stop would become even more devastating. Could such a catastrophic event actually happen? Is there anything in the universe that could bring Earth's rotation to an abrupt halt? In the next section, we'll explore whether this scenario is scientifically possible, and what it would take to stop a spinning planet. Section 3: Ideographic comma. Is it scientifically possible? We've explored what would happen if Earth suddenly stopped spinning. A disaster of unimaginable scale. But could such an event actually occur? Is there any scientific possibility that Earth's rotation could suddenly come to a halt? Let's examine the physics behind it. First, we need to understand why Earth spins in the first place. Our planet was born from a swirling cloud of gas and dust about 4.5 billion years ago. As gravity pulled this material together, the conservation of angular momentum caused it to spin, just like a figure skater pulling their arms in to spin faster. Since space is a near-perfect vacuum with no external force acting against this motion, Earth has continued spinning for billions of years with little change. To stop the Earth's rotation suddenly, an enormous force would have to be applied. The amount of energy required to bring the planet to a dead stop is nearly unimaginable. For context, Earth has an immense amount of rotational energy, about 10 to the power of 29 joules, which is more than 1 trillion times the energy of all nuclear weapons ever detonated combined. The only conceivable way to halt this rotation instantly would be a cosmic-scale event, such as a direct collision with a Mars-sized object. However, Even in the event of a massive asteroid impact, Earth wouldn't stop spinning instantly. Instead, its rotation might be slightly altered, or slowed over millions of years. This is exactly what happened with the Moon. Scientists believe that billions of years ago, a collision with a planet-sized object led to the formation of the Moon and slowed Earth's rotation slightly. Even today, tidal interactions with the Moon are gradually reducing Earth's rotational speed, though only by about 1.7 milliseconds per century. Another hypothetical way to stop Earth's rotation is through the influence of an incredibly strong gravitational force, such as a close encounter with a supermassive black hole. The tidal forces from such an object could, in theory, disrupt Earth's rotation. However, the effects would be catastrophic long before that, with our planet likely being torn apart before it ever stopped spinning. So, is it possible for Earth to stop spinning? The answer is no, at least not suddenly. The laws of physics and the vast energy required make an instantaneous stop virtually impossible. However, Earth's rotation is gradually slowing down over time due to tidal forces. In about 50 billion years, it's estimated that Earth's rotation could slow to the point where one side permanently faces the Sun, much like how the Moon always shows the same face to Earth. While we don't need to worry about the Earth stopping anytime soon, understanding the forces at play helps us appreciate the delicate balance that makes life on our planet possible. In the next chapter, we'll look at what happens in the long term after a world-changing event like this, including the impact on climate and the very survival of life itself. Chapter 2: Immediate Catastrophic Effects. Section 1: Everything would be flung at tremendous speed. If Earth were to stop spinning suddenly, the first and most immediate consequence would be inertia in action. Right now, everything on the planet's surface, land, water, and even the air, moves along with Earth's rotation at tremendous speed. The moment that motion stops, everything would continue moving forward at the same velocity, creating a global-scale disaster. At the equator, the Earth's surface is spinning at about 1,670 kilometers per hour, 1,037 miles per hour. This means that everything not anchored deep into the ground would be hurled eastward at supersonic speeds. Buildings would collapse instantly, vehicles would be thrown like projectiles, and even entire forests could be uprooted in an instant. The further from the equator you are, the slower the movement, but even at mid-latitudes, the effects would still be catastrophic. For humans, survival would be nearly impossible. The sudden deceleration would create an effect similar to a high-speed car crash, except that it would happen on a planetary scale. Most people would be launched into the air, colliding with objects or the ground with fatal force. Only those in underground shelters or deep inside mountains might have a chance to survive the initial impact. The destruction wouldn't stop with land-based objects. The oceans, which also move with the Earth's rotation, would behave like a massive, uncontrolled wave. Enormous megatsunamis would form, sweeping across continents at incredible speeds. Coastal cities would be obliterated within minutes, and even inland regions would experience catastrophic flooding as water surges unpredictably across the land. Even the atmosphere wouldn't stop moving instantly. The air, which was previously circulating in sync with the planet, would continue rushing forward at extreme speeds. This would create winds stronger than any hurricane ever recorded, reaching speeds of over 1,000 kilometers per hour, 620 miles per hour in some areas. These winds alone could flatten entire cities, uproot trees, and turn debris into deadly projectiles. The sheer force of this sudden stop would fundamentally change the planet in a matter of seconds. But this is just the beginning. In the next section, we'll explore how the chaos continues as the oceans and atmosphere spiral further out of control, reshaping the entire planet's landscape. Section 2. The atmosphere and oceans go wild. The Earth's sudden stop wouldn't just throw objects and people eastward. It would also unleash absolute chaos in the atmosphere and oceans. Unlike the solid ground, which would stop instantly, the air and water would continue moving at extreme speeds, creating storms and tsunamis on a scale never before seen. Let's start with the atmosphere. Right now, the air moves with the Earth's rotation, creating stable wind patterns and weather systems. But if the planet stopped spinning, the air would keep moving at its original speed, over 1,600 kilometers per hour. 1,000 miles per hour at the equator. That's faster than the speed of sound. These winds would be more violent than any tornado or hurricane ever recorded, capable of flattening entire cities, stripping forests bare, and turning even small debris into lethal projectiles. The effects wouldn't be the same everywhere. Near the poles, where rotational speed is much lower, the winds would be weaker. But they would still be strong enough to tear apart structures. Meanwhile, at the equator, these supersonic winds would cause immense friction as they collide with mountains, buildings, and the uneven surface of the land. This could generate enough heat to spark wildfires on a planetary scale. Then, we have the oceans. Unlike the atmosphere, which is light and disperses quickly, water is dense and incredibly powerful. When the Earth stops, its oceans, containing 1.4 billion cubic kilometers of water, would be thrown forward with unstoppable force. The result? Megatsunamis hundreds of meters high, racing across continents and swallowing entire regions. Coastal cities would be the first to disappear. Places like New York, Tokyo, and London would be wiped out in seconds as walls of water taller than skyscrapers crash down on them. But the destruction wouldn't stop at the coast. These tsunamis would travel hundreds or even thousands of kilometers inland, reaching areas that have never seen the ocean before. As the water surges forward, it would carve new landscapes, erasing old coastlines and reshaping entire continents. Rivers would overflow and reverse course, turning once fertile valleys into underwater wastelands. The redistribution of so much water would also cause dramatic shifts in pressure on the Earth's crust, triggering earthquakes and volcanic eruptions worldwide. The combination of unstoppable winds and raging oceans would turn the planet into an unrecognizable wasteland. The few survivors, if any, would face a world where the very air and water have become deadly forces. But this is only the beginning. As the planet adjusts to its new motionless state, long-term environmental changes would make survival even harder. In the next section, we'll explore how the sudden stop would disrupt Earth's climate forever, leading to a world of extremes. One half in permanent daylight, the other in eternal darkness. Section 3. Massive earthquakes and crustal shifts. If the Earth were to suddenly stop spinning, the chaos wouldn't just be limited to the atmosphere and oceans. The planet's very crust would be torn apart by unimaginable forces. Beneath our feet, the ground might seem solid and stable, but in reality, the Earth's outer shell is made up of massive plates that float on a layer of semi-molten rock. When the planet's rotation stops, these plates would experience a sudden, violent jolt, triggering some of the most powerful earthquakes and volcanic eruptions in history. Tectonic plates typically move at a slow and steady pace, shifting just a few centimeters per year. But if the Earth stopped rotating in an instant, the sudden deceleration would send shockwaves rippling through the entire crust. Fault lines across the globe, such as the San Andreas Fault in California, or the Ring of Fire in the Pacific, would rupture all at once, producing earthquakes far more powerful than anything we've ever recorded. Cities would be leveled instantly, mountains could collapse, and massive landslides would bury entire regions. But earthquakes wouldn't be the only problem. The redistribution of mass caused by the halt in rotation would have dramatic effects. Right now, Earth's rotation causes a slight bulge at the equator, making the planet an oblate spheroid rather than a perfect sphere. If the rotation stopped, this bulge would slowly begin to disappear, forcing the oceans to migrate toward the poles. This would cause severe land deformation, with some areas being submerged while others rise from the ocean. Imagine entire coastal regions sinking, while new land masses emerge in previously submerged areas. Then, there are the volcanoes. Many volcanoes around the world are already under pressure from shifting tectonic plates. A sudden planetary jolt would be enough to trigger widespread volcanic eruptions, spewing ash, lava, and toxic gases into the atmosphere. The resulting ash clouds could block out sunlight for months, further worsening the catastrophic conditions on the planet. With earthquakes, land shifts, and volcanic eruptions happening all at once, survival would be nearly impossible. Even if someone managed to escape the winds and tsunamis, the ground beneath them could split apart at any moment. Entire landscapes would be reshaped in days, leaving the Earth unrecognizable. But this is just the beginning of the planet's transformation. In the next chapter, we'll explore what happens in the long run, how a world without rotation would face permanent climate extremes, with one half of the planet locked in eternal day and the other in everlasting night. Chapter 3: Climate and Environmental Impact. Section 1: One side freezes, one side burns. With Earth's rotation permanently stopped, a new and terrifying climate would emerge. The planet, once governed by the steady cycle of day and night, would now be locked in an extreme state, one half bathed in constant sunlight, the other trapped in eternal darkness. The consequences would be nothing short of apocalyptic. Let's start with the day side, the half of the planet facing the sun. Without rotation, this side would be exposed to continuous solar radiation, with no night to provide cooling. Over time, temperatures would soar to unbearable levels, likely exceeding 100 degrees Celsius, or 212 degrees Fahrenheit or more, making oceans boil and turning land into a vast desert wasteland. Water sources would evaporate rapidly, creating massive, suffocating clouds of steam. This excessive heat would also lead to violent superstorms, with towering thunderclouds and hurricane-force winds constantly battering the surface. Meanwhile, on the night side, the exact opposite would occur. With no sunlight to provide warmth, temperatures would plummet far below -100 degrees Celsius, or -148 degrees Fahrenheit, creating a frozen, airless wasteland similar to the dark side of the moon. The oceans would freeze over, forming miles-thick layers of ice. Any remaining atmosphere on this side would begin to condense and fall as frozen nitrogen and oxygen, making it impossible to breathe. Between these two extremes, there would be a thin twilight zone, a narrow strip of land where temperatures might be somewhat tolerable. This area, where the sun would eternally hover on the horizon, could theoretically support life. but only if the planet's atmosphere remained stable. Unfortunately, that's unlikely. The stark contrast between the scorching day side and the frozen night side would create an atmospheric nightmare, with hot air constantly rising on the sunlit side and cold air sinking on the dark side. The resulting winds would reach unimaginable speeds, likely exceeding anything seen on Earth today. These winds would drive massive dust storms, acid rain, and unpredictable climate shifts that could make even the twilight zone uninhabitable. Earth, as we know it, would be gone. Instead, it would resemble a hellish version of Mercury, with one half burning under endless sunlight and the other locked in icy desolation. The balance that once made life possible would be completely shattered. But what about life itself? Could anything survive in this new, hostile world? In the next section, we'll explore how the breakdown of atmospheric circulation would push Earth's ecosystems past the point of no return. Section 2. Atmospheric circulation breakdown. If Earth's rotation stopped, the planet's atmosphere wouldn't stay calm. In fact, the difference between the scorching day side and the frozen night side would create some of the most extreme weather conditions imaginable. The stable wind patterns that once regulated Earth's climate would collapse, giving rise to massive, never-ending storms that would reshape the planet's surface. Normally, Earth's rotation drives the Coriolis effect, which influences wind patterns and ocean currents. This effect helps distribute heat evenly across the planet. Without rotation, however, the Coriolis effect would disappear, and global wind patterns would shift into a completely different and chaotic state. On the day side, as the sun continuously heats the land and oceans, hot air would rise endlessly, creating a permanent superstorm that could stretch across entire continents. Towering thunderclouds would form massive hurricane-like systems, swirling unpredictably without the Coriolis effect to guide them. These storms would be fueled by the extreme heat and evaporation of the oceans, producing violent lightning, acid rain, and deadly winds that could exceed 1,000 kilometers per hour, 620 miles per hour. On the night side, cold, dense air would sink toward the surface, forming a stagnant, oxygen-starved wasteland. The absence of sunlight would cause the atmosphere to condense and freeze, leading to layers of frozen gases settling on the surface. The thin air would become unbreathable, making survival impossible without artificial protection. Between these two extremes, the twilight zone, the narrow region between the day and night sides, might seem like a refuge. But it would be anything but peaceful. The intense contrast in temperature would create violent wind currents as hot air from the day side rushed toward the freezing night side. These winds would be stronger than anything Earth has ever experienced, reaching supersonic speeds in some regions. The disappearance of Earth's regular wind and ocean currents would also destroy the planet's climate stability. With no rotation to distribute heat, rainfall patterns would become erratic, and many regions would experience either permanent drought or endless storms. The Earth would become a place of extremes, where any remaining habitable zones would constantly shift, forcing species, if any survived, to adapt or perish. Without a functioning climate system, Earth's ecosystems would collapse. Plants, which rely on predictable weather cycles, would struggle to survive in these erratic conditions. With plant life disappearing, herbivores would starve, followed by the predators that depend on them. The food chain would unravel, and Earth would enter a new, unpredictable phase of its existence. But even with this environmental collapse, some forms of life might still find a way to survive. In the next section, we'll explore how Earth's biosphere would be affected. and whether any species could endure in this brutal, post-rotation world. Section 3. The destruction of ecosystems. With the Earth's rotation stopped, the planet's ecosystems would face total collapse. Every form of life, from microscopic bacteria to the largest animals, depends on the delicate balance of climate, temperature, and atmospheric circulation. When that balance is destroyed, so is the foundation of life itself. Let's start with the plants. Without rotation, half of the planet would be exposed to constant, scorching sunlight, while the other half would be trapped in eternal darkness. On the day side, the intense heat and lack of night would lead to rapid dehydration. Plants would wither as the soil dried out, and without moisture, entire forests would become fuel for massive wildfires that never stop burning. Meanwhile, on the night side, the extreme cold would cause water to freeze permanently, making plant growth impossible. Without sunlight, photosynthesis, the process that plants use to generate energy, would completely cease, cutting off the very foundation of the food chain. With plant life gone, herbivores would starve. Without them, carnivores would soon follow. Even scavengers, which rely on decaying organic matter, would eventually run out of food. The collapse of plant and animal life would create a domino effect, wiping out entire ecosystems in just a matter of months. But what about the oceans? After all, they cover more than 70% of Earth's surface and have historically been more resistant to environmental changes. Unfortunately, even marine life wouldn't be spared. On the day side, ocean temperatures would skyrocket, boiling away large portions of the water and leaving behind vast salt flats. Marine creatures would either die from extreme heat or migrate toward the remaining deep-sea regions, if they even survive that long. On the night side, the ocean would freeze over completely, locking marine life beneath a thick layer of ice. Some of the last survivors might be extremophiles, microorganisms that thrive in extreme conditions. Certain bacteria, which can survive in deep-sea hydrothermal vents or beneath ice sheets, might persist for a while. But even these resilient life forms would struggle. In a world where the entire biosphere is collapsing, eventually, Earth would become nearly lifeless, resembling a barren exoplanet rather than the vibrant world we know today. However, this transformation wouldn't happen overnight. Some species might cling to existence in deep caves, deep-sea trenches, or even artificial shelters built by humans, if any survived the initial catastrophe. But if life did find a way to endure, what kind of planet would they inherit? In the next chapter, we'll explore how the collapse of Earth's magnetic field would expose the planet to deadly cosmic radiation, further pushing life to the brink of extinction. Chapter 4. Magnetic Field Collapse and Cosmic Radiation Threats. Section 1. How Earth's Magnetic Field Protects Us. Earth's magnetic field is an invisible shield, quietly protecting all life from deadly radiation. Without it, the planet would be bombarded by harmful cosmic rays, solar storms, and charged particles from space, threats that could wipe out the last remnants of life. Struggling to survive in a motionless world. But how does this magnetic shield work? The Earth's core is made of molten iron and nickel, which constantly moves due to the planet's rotation. This movement creates electric currents, which in turn generate the geomagnetic field that extends far into space. It deflects solar wind, a stream of charged particles emitted by the sun, preventing it from stripping away our atmosphere and exposing us to deadly radiation. If the Earth stopped spinning, this core movement would gradually slow and eventually cease. leading to a complete collapse of the magnetic field. The consequences would be catastrophic. First, without a magnetic field, Earth would become vulnerable to solar storms. The Sun regularly releases massive bursts of charged particles, known as coronal mass ejections (CMEs). Normally, our magnetic field shields us from these storms, but without it, these energetic particles would strike the atmosphere directly, causing massive disruptions. Electrical systems, satellites, and communication networks would be permanently disabled, making technological survival nearly impossible. Second, cosmic radiation would reach the surface unfiltered. Right now, the magnetic field deflects much of this radiation, protecting living organisms from its harmful effects. Without this barrier, levels of radiation on the surface would skyrocket. DNA mutations, increased cancer rates, and widespread biological damage would make survival even harder for any remaining life forms. Third, our atmosphere itself would begin to erode. The constant bombardment of charged particles would slowly strip away the upper layers of the atmosphere, allowing more ultraviolet and cosmic radiation to penetrate the surface. Over time, Earth could lose much of its atmosphere, becoming more like Mars, a dry, barren wasteland with only a thin layer of air remaining. With the climate already devastated and radiation levels rising, the few survivors left on Earth would face an impossible challenge. But how quickly would this happen? And could anything stop it? In the next section, we'll explore how fast Earth's magnetic field would decay, and whether humanity could find a way to restart it before it's too late. Section 2. The consequences of a magnetic field breakdown. With Earth's rotation stopped, the magnetic field would begin to fade, leaving the planet vulnerable to cosmic radiation and atmospheric decay. But how fast would this happen? And what would it mean for the last surviving life on Earth? At first, the magnetic field wouldn't disappear instantly. Studies suggest that if the Earth's core stopped moving, it could take thousands of years for the magnetic field to fully collapse. However, even a gradual weakening would be enough to cause devastating consequences. One of the first noticeable effects would be a dramatic increase in radiation exposure. Without the magnetic shield deflecting charged particles, the surface would be bombarded by high-energy cosmic rays and solar radiation. This radiation would be strong enough to damage DNA, increasing the risk of cancer and mutations. The last surviving humans, if any remained, would need to seek permanent shelter underground or inside heavily shielded structures to avoid deadly radiation exposure. Next, the atmosphere itself would start to erode. The constant bombardment of solar wind would slowly strip away Earth's upper atmospheric layers. This process has already been observed on Mars, which lost most of its atmosphere billions of years ago when its magnetic field weakened. If the same happened to Earth, the air would thin, temperatures would drop further, and oxygen levels would decline, making survival nearly impossible outside of artificial habitats. Another consequence would be the collapse of the ozone layer. Without the magnetic field's protection, ultraviolet UV radiation from the sun would penetrate the atmosphere in higher concentrations, exposing any remaining life to extreme radiation levels. This would make the surface even more uninhabitable, effectively sterilizing whatever regions hadn't already been destroyed by climate collapse. As Earth's environment deteriorated, the planet would start resembling a mix between Mars and Venus, a world with a thin, hostile atmosphere, extreme radiation, and no protection from space weather. The only chance of survival for any species would be in deep-sea trenches. underground bunkers, or enclosed habitats built by an advanced civilization, if any still existed. But is there any way to stop this process? Could humanity, or even natural geological forces, somehow restart Earth's magnetic field before it's too late? In the next section, we'll explore whether science offers any hope for reversing the collapse of Earth's most crucial shield. Section 3. Cosmic radiation and the risk to life. Without Earth's magnetic field, the planet would be defenseless against cosmic radiation. This invisible but deadly force, constantly bombarding the universe, has the power to alter DNA, accelerate cancer, and wipe out entire ecosystems. For any remaining life on Earth, exposure to this radiation would be one of the final challenges in an already dying world. Right now, Earth's magnetic field and atmosphere work together as a dual shield, protecting us from high-energy radiation coming from both the sun and deep space. This includes solar wind, coronal mass ejections (CMEs), and cosmic rays, streams of high-energy particles traveling at nearly the speed of light. Normally, these particles are deflected by the magnetic field, or absorbed by the atmosphere. But without this protection, radiation levels on the surface would skyrocket. The effects would be immediate and devastating. Ultraviolet UV radiation would increase, causing severe damage to any remaining plant life. Trees, crops, and algae, key sources of oxygen, would struggle to survive under extreme radiation, further reducing the planet's ability to support life. Animals and humans exposed to direct sunlight would suffer from radiation burns, weakened immune systems, and increased cancer rates. In addition, cosmic rays from deep space would reach the surface unfiltered. These rays are far more energetic than solar radiation, and can penetrate deep into biological tissue, damaging cells beyond repair. Over time, prolonged exposure would cause widespread genetic mutations, accelerating the extinction of whatever species had managed to survive. But it wouldn't just affect life on the ground. Without a magnetic field, Earth's atmosphere would slowly leak into space. The same process happened to Mars billions of years ago, when its magnetic field collapsed. Over time, solar wind stripped away its atmosphere, leaving behind the cold, barren desert we see today. If Earth followed the same path, the remaining oxygen would dissipate, turning our once thriving world into a lifeless rock. Is there any way to survive this cosmic assault? The only safe havens would be deep underground or beneath thick layers of water, where radiation exposure is lower. Some microorganisms, particularly extremophiles that thrive in extreme conditions, might persist in deep-sea vents or buried beneath the surface. But for larger life forms, including humans, long-term survival would require advanced shielding, artificial atmospheres, and underground cities. As Earth's environment becomes more hostile, the question remains: could humanity find a way to restart the magnetic field or adapt to a world without it? In the next chapter, we'll explore the end of human civilization, and whether any future remains for life on a motionless Earth. Chapter 5. The End of Human Civilization. Section 1. The Collapse of Power Grids and Communication Systems. With Earth's rotation stopped and the magnetic field fading, civilization would face one of its final collapses: the breakdown of power grids, communication networks, and modern infrastructure. In a world already plagued by violent storms, radiation, and uninhabitable conditions, losing electricity and global communication would push humanity to the brink of extinction. Modern society depends entirely on a stable electrical grid. Power plants generate electricity by harnessing natural forces such as coal, nuclear reactions, and hydroelectric dams, all of which assume a planet with predictable environmental conditions. But in a world where the climate has spiraled into chaos, maintaining any power source would be nearly impossible. First, the intense solar radiation and cosmic rays would cause frequent disruptions in electrical systems. Without the magnetic field acting as a shield, geomagnetic storms from the sun would directly hit the Earth, overloading electrical grids and short-circuiting transformers. These storms have already caused blackouts in the past, such as the Carrington event of 1859, which disrupted telegraph lines worldwide. In a world without a protective magnetosphere, these effects would be much worse, causing permanent damage to power systems. Second, satellites and global communication would fail. The Earth's upper atmosphere, now directly exposed to solar wind, would be bombarded with high-energy particles that would destroy satellites in orbit. Without satellites, GPS systems would shut down, global internet services would collapse, and long-distance communication would become impossible. Any remaining survivors would be cut off from each other, left in isolated pockets, with no way to coordinate survival efforts. Third, the loss of electricity would mean the failure of water purification, food production, and medical infrastructure. Refrigeration would cease, leading to widespread food spoilage. Clean water would become scarce as pumps and filtration systems stopped working. Medical supplies that require refrigeration, such as insulin and vaccines, would expire, making disease outbreaks far more deadly. Even nuclear power plants, which seem like a reliable energy source, would eventually fail. Without a functioning grid to regulate them, their cooling systems would stop working, leading to meltdowns and massive radiation leaks, making parts of the world even more uninhabitable. With the power grid gone, humanity would be forced back into a pre-industrial state, relying on fire, crude tools, and whatever resources could still be salvaged. But in a world where most of the planet is either boiling, frozen, or irradiated, survival would be nearly impossible. Could any part of civilization still function? In the next section, we'll explore whether any region on Earth could still support life, or if the last remnants of humanity are doomed to disappear. Section 2. Where could humans survive? With Earth transformed into a planet of extremes, is there anywhere left for humans to survive? The answer depends on finding a delicate balance between temperature, resources, and protection from radiation. In a world where one side is scorching under endless sunlight, and the other is frozen in eternal darkness, only a few places could still offer a chance at life. The most promising area would be the twilight zone, the narrow band between the burning day side and the frozen night side. Here, temperatures might be mild enough to support life, with regions of perpetual sunset offering some level of stability. However, this zone would be constantly battered by extreme winds. As air rushes from the hot to the cold side, the strongest winds could exceed 1,000 kilometers per hour, 620 miles per hour, turning the air itself into a deadly force. Any surviving humans would need underground shelters to avoid being swept away. But temperature isn't the only concern. Water is essential for survival. On the day side, liquid water would rapidly evaporate, creating a vast, dry wasteland. On the night side, any remaining water would freeze solid, becoming permanently inaccessible. The twilight zone, once again, would be the only place where water might still exist in liquid form. However, with violent weather and unpredictable ocean shifts, water sources could be unstable, forcing survivors to constantly relocate. Radiation presents another deadly challenge. With Earth's magnetic field weakened or gone, cosmic radiation and ultraviolet exposure would be extreme. The twilight zone might receive less direct sunlight than the day side. But it wouldn't be enough to prevent long-term DNA damage and increased cancer rates. Survivors would need thick shelters, underground bunkers, or natural cave systems to shield themselves. Another potential survival option? Deep-sea environments. The ocean's depths provide natural protection from radiation and temperature extremes, and certain deep-sea ecosystems, like hydrothermal vent communities, might remain stable. However, accessing and maintaining an underwater habitat would be incredibly difficult, requiring advanced technology and long-term planning, something humanity may not have the resources for in a collapsing world. If humans did manage to find shelter, what kind of civilization could they build? With no power grid, no global communication, and extreme environmental hazards, life would be primitive and isolated. Small groups of survivors might form underground or underwater communities, struggling to maintain food, water, and energy sources. But with dwindling supplies and no ability to grow food in a ruined ecosystem, even these settlements might not last long. So, is there any real future for humanity on this new Earth? In the next section, we'll explore whether humans could adapt and rebuild, or if the last survivors are merely delaying the inevitable. Section 3. Could humanity adapt and rebuild? If any humans manage to survive the initial catastrophe, finding shelter in underground bunkers, deep-sea habitats, or the twilight zone, could they eventually rebuild civilization? Or would they be living on borrowed time in a world that can no longer sustain life? One of the biggest challenges would be food production. Traditional agriculture would be impossible. The dayside would be too hot and dry, scorching crops before they could grow. The night side would be too cold, with frozen soil preventing plant life. Even in the twilight zone, unpredictable storms, high winds, and radiation would make farming nearly impossible. Survivors would have to rely on hydroponic or underground farming. But without electricity or a stable infrastructure, maintaining a food supply would be a constant struggle. Water would be equally scarce. Glaciers on the night side could serve as a water source, but they would need to be melted and transported. Deep-sea reserves might be available, but accessing them without advanced technology would be difficult. Even if survivors could find water, purification systems would be essential to remove contamination from radiation exposure. Then, there's the issue of energy and shelter. With the power grid completely destroyed, survivors would have to find alternative energy sources. Solar power might work in the twilight zone, but constant storms and dust could limit its effectiveness. Geothermal energy from underground heat sources could be a possibility, but only in locations where volcanic activity remains stable. In the absence of power, humans would be forced to live in permanent darkness, relying on fire and primitive tools. Socially, survival would depend on small, isolated communities, as global communication would no longer exist. The loss of knowledge and technology over generations could lead to a return to a pre-industrial society, where survival is based purely on physical endurance and resource management. With such limited habitable space, conflicts over resources would be inevitable, making cooperation essential for long-term survival. But even if humanity adapted to these extreme conditions, there's still one final problem. Earth itself is no longer a stable home. With its magnetic field gone, radiation levels increasing, and the atmosphere slowly escaping into space. The planet would continue deteriorating for thousands of years. Eventually, even the few remaining habitable zones could become unlivable. So, could humans truly rebuild? The answer is bleak. Even if small groups manage to survive for centuries, they would be fighting against an environment that is actively trying to wipe them out. The only real hope for long-term survival might not be on Earth at all. In the next chapter, we'll explore the final, ultimate question. If Earth can no longer sustain us, could humanity escape to another world before it's too late? Chapter 6. What if the Earth started spinning again? Section 1. Possible scenarios for restarting rotation. With Earth locked in a motionless state, battered by radiation, climate extremes, and ecological collapse, one question remains. Could the planet ever start spinning again? While it may seem impossible, some hypothetical scenarios could, in theory, set Earth back into motion. But would that really solve our problems? One way Earth's rotation could restart is through a massive asteroid impact. If a planet-sized object, similar to the one that created the Moon, were to collide with Earth at just the right angle, it could transfer enough momentum to initiate a slow rotation. However, the impact itself would be an extinction-level event, wiping out any remaining survivors. Even if rotation were restored, it would take millions of years for Earth's climate and ecosystems to stabilize again. Another scenario involves gravitational interactions with a passing celestial body. If a rogue planet or a nearby star passed close enough, its gravitational pull could exert a tidal force strong enough to create rotational motion. However, such an event would likely cause even more destruction, triggering earthquakes, tsunamis, and further destabilizing the planet's orbit. A more speculative possibility involves advanced technology. If humanity, or an advanced alien civilization, discovered a way to manipulate planetary motion, they might attempt to restart Earth's rotation using massive thrusters, nuclear detonations, or gravitational assist techniques. However, the sheer energy required would be far beyond our current technological capabilities. Even with the most powerful nuclear devices ever created, we wouldn't come close to generating the necessary force. But here's the biggest problem. Even if Earth started spinning again, the damage has already been done. The atmosphere is already deteriorating, the magnetic field has collapsed, and the oceans and climate systems have been irreversibly altered. Restarting rotation wouldn't magically restore the planet to its former state. In fact, it could make things even worse, triggering new environmental disasters as the planet struggles to readjust to motion. In the end, while it's fascinating to consider the idea of restarting Earth's spin, the reality is that it would not save us. The conditions that once made Earth habitable are gone, and no amount of rotation would bring them back. So, if Earth can no longer sustain life, is there any hope left for humanity? In the next section, we'll explore what happens to gravity, tides, and the planet's structure if rotation were somehow restored, and whether survival is even possible in a world trying to move again. Section 2. Effects on gravity and tides. If Earth somehow started spinning again, the consequences would be just as catastrophic as when it stopped. Restarting rotation wouldn't simply reset the planet to its former state. It would unleash a new wave of destruction, reshaping the environment, oceans, and even gravity itself. Let's start with gravity. While Earth's overall gravitational pull wouldn't change, its effects on the surface would shift dramatically. Right now, Earth's rotation causes a slight bulging at the equator due to centrifugal force, making the planet an oblate spheroid rather than a perfect sphere. If rotation resumed, this bulging effect would return, but not gradually. Instead, landmasses, oceans, and even the air itself would experience violent redistribution, causing earthquakes, landslides, and massive structural collapses worldwide. The oceans would be hit even harder. When Earth first stopped spinning, water surged toward the poles, leaving equatorial regions dry. If rotation restarted, all that displaced water would come rushing back toward the equator, triggering planet-wide megatsunamis. Coastal regions would be completely erased, and inland areas that had been dry for centuries could suddenly find themselves underwater. These tsunamis wouldn't last for minutes or hours, they could continue for years. As Earth struggled to find a new equilibrium, then there are the tides. Earth's tides are controlled by the Moon's gravitational pull, but they are also influenced by the planet's rotation. With a sudden return to motion, the balance between lunar gravity and rotational force would be thrown into chaos. The result? Unpredictable, extreme tidal waves, with water surging back and forth chaotically. In some areas, tides might disappear completely, while in others, they could rise to unprecedented heights, flooding vast regions permanently. The atmosphere would also struggle to readjust. The sudden return of the Coriolis effect, the force that influences wind patterns, would cause massive, planet-wide storms as air currents violently realigned. Tornadoes, hurricanes, and wind speeds exceeding 1,000 kilometers per hour (620 miles per hour) could devastate any remaining structures, making the surface even more uninhabitable. For any survivors left on Earth, a restarting rotation wouldn't be salvation, it would be another apocalyptic event. Instead of bringing balance back to the planet, it would create new disasters, further reducing the chances of long-term survival. So, if restarting rotation isn't the answer, what would happen to Earth in the long term? Would it eventually settle into a new stable state, or would it continue to deteriorate beyond the point of no return? In the next section, we'll explore what the planet's final fate might be, and whether any future remains for life on Earth. Section 3. The New Face of Earth. If Earth somehow survived the chaos of restarting its spin, what kind of planet would be left behind? Would it return to its former state, or would it become something entirely new? The answer lies in the long-term effects of climate collapse, geological shifts, and atmospheric changes. First, Earth's landscapes would be permanently altered. The violent redistribution of water would have reshaped coastlines, submerging some continents while exposing new landmasses. Entire regions could be lost beneath the ocean, while former seabeds might become new deserts or mountain ranges. Earth's geography as we know it would be unrecognizable. The atmosphere would also struggle to stabilize. The return of rotation would reinstate global wind patterns, but these wouldn't simply pick up where they left off. Instead, superstorms could rage for decades as the planet adjusted, making the surface a dangerous and unpredictable place. Radiation from space would remain a problem, as Earth's magnetic field, once lost, wouldn't regenerate instantly. Even if the core restarted its motion, it could take thousands of years for the magnetic shield to recover, leaving the surface exposed to cosmic rays for generations. As for climate, the new Earth would likely have extreme, unpredictable weather. Some regions might stabilize into new habitable zones, but many areas would remain locked in perpetual droughts, floods, or freezing conditions. Even if life managed to adapt, the biosphere wouldn't simply return to what it was before. Many species, especially humans, would struggle to survive in this unstable world. Speaking of humanity, could civilization rebuild in such an environment? If small survivor groups managed to endure the initial disasters, they would need generations to adapt to this new world. Societies would likely be isolated, spread across whatever regions remained habitable. Technology, agriculture, and industry would have to be rebuilt from scratch, and survival would depend on securing resources. In a world that had changed beyond recognition, ultimately, even if Earth stabilized, it would never be the same planet it once was. It would be a harsher, more dangerous world, where survival would be far from guaranteed. The question is, if given the chance, should humanity even stay? Or would our best hope for survival lie not on this broken Earth, but somewhere beyond the stars? In the next chapter, we'll explore the ultimate question: if Earth can no longer sustain life, could humanity escape to another world? Chapter 7: Conclusion and Scientific Insights. Section 1: Could this actually happen? We've explored the terrifying consequences of Earth suddenly stopping its rotation. Massive global destruction, extreme climate shifts, the collapse of ecosystems, and the downfall of human civilization. But how realistic is this scenario? Could Earth actually stop spinning? Or is this purely science fiction? The short answer is no, at least not suddenly. Earth's rotation is governed by the laws of physics, particularly the conservation of angular momentum. This principle states that a spinning object, like a planet, will continue to spin unless acted upon by an external force. Given Earth's immense size and energy, the amount of force required to stop it instantly would be unfathomable. To put this into perspective, Earth's rotational energy is approximately 10 to the power of 29 joules, equivalent to 1 trillion times the energy of all nuclear weapons ever detonated combined. Stopping this motion would require an impact so enormous that it would likely shatter the planet itself. Even the most massive asteroid collisions in Earth's history, such as the one that wiped out the dinosaurs 66 million years ago, barely made a dent in our planet's spin. However, Earth is slowing down, but at an extremely gradual rate. The gravitational pull of the Moon creates tidal forces that act as a brake, slowing Earth's rotation by about 1.7 milliseconds per century. At this rate, it would take billions of years for Earth to stop spinning completely. If nothing else interferes, our planet could eventually become tidally locked to the Moon, meaning one side of Earth would always face the Moon, much like how the Moon always shows the same face to Earth. But are there any catastrophic events that could drastically alter Earth's rotation? Theoretically, yes. A collision with a Mars-sized object, similar to the one that likely formed the Moon billions of years ago, could significantly alter Earth's spin. However, such an impact would cause global devastation, likely making any discussion of rotation irrelevant. Similarly, if a supermassive object, like a rogue planet or a passing black hole, came close enough, its gravitational force could disrupt Earth's rotation. But again, the destruction from such an encounter would be beyond apocalyptic. So, while a sudden stop is physically impossible, a gradual slowing is inevitable. This raises an important question. What will happen to Earth's rotation in the distant future? Will humans need to adapt to longer days? Or will technology allow us to counteract these effects? In the next section, we'll explore the long-term fate of Earth's rotation and how it could shape the planet's future. Section 2: The future of Earth's rotation. While Earth won't suddenly stop spinning, its rotation is gradually slowing down over millions and billions of years. This process will continue, leading to profound changes in our planet's future. But what exactly will happen? And how will it affect life on Earth? The primary reason for this slowdown is tidal friction caused by the Moon. As Earth spins, the gravitational pull of the Moon creates ocean tides. These tides, in turn, generate friction between the water and the ocean floor, slowly but steadily stealing rotational energy from the planet. Right now, this process is extending the length of a day by about 1.7 milliseconds per century. That may seem insignificant, but over millions of years, it adds up. In about 2 billion years, if Earth and the Moon remain unchanged, a day could last 30 hours instead of 24. But that's not the only consequence. The Moon is also slowly drifting away from Earth at a rate of 3.8 centimeters (1.5 inches) per year. As it moves farther away, its gravitational influence will weaken, which could disrupt Earth's climate over long timescales. Looking even further ahead, in about 50 billion years, Earth could become tidally locked to the Moon. This means one side of the Earth would always face the Moon, just as the Moon always shows the same face to Earth. If this happens, half of the planet would experience perpetual daylight, while the other half would be stuck in eternal night, similar to what would happen if Earth's rotation suddenly stopped, but on a much slower timescale. However, there's another factor at play: the Sun. In about 5 billion years, the Sun will expand into a red giant, engulfing Mercury, Venus, and possibly Earth. If our planet isn't consumed, it will be completely transformed by the intense heat, boiling away the oceans and leaving behind a scorched, lifeless world. At this stage, Earth's rotation, or lack of it, will no longer matter. Could humans do anything to counteract this slowing rotation? With advanced technology, it might be possible to artificially speed up Earth's rotation using massive space-based engines or gravitational manipulation. However, the energy required for such an operation would be staggering, far beyond anything we can currently achieve. Ultimately, Earth's rotation will continue changing, but its fate is tied to far larger cosmic forces. The slowing of its spin may reshape the planet, but in the grand scale of time, it will be the evolution of the Sun, the Moon, and the universe itself that determines Earth's ultimate future. In the next section, we'll reflect on what we've learned and what this thought experiment reveals about the delicate balance that makes life on Earth possible. Section 3. Lessons we can learn. Through this thought experiment, we've explored a terrifying scenario, Earth suddenly stopping its rotation, and examined the catastrophic consequences that would follow. While such an event is physically impossible, the exercise has revealed some fundamental truths about our planet and the delicate balance that makes life possible. First, we've seen how Earth's rotation is essential for life as we know it. It regulates day and night, ocean currents, wind patterns, and climate stability. Without it, our planet would become a world of unbearable extremes. One half scorched, the other frozen. Even the smallest changes in Earth's rotational speed can have profound effects on weather, tides, and ecosystems. Second, this scenario has highlighted the importance of Earth's magnetic field. Without it, our planet would be bombarded by deadly cosmic radiation, and over time, the atmosphere itself could be stripped away. Earth would become as barren as Mars, proving that our magnetic shield is one of the most critical factors in sustaining life. Third, we've seen that even though Earth won't suddenly stop spinning, its rotation is gradually slowing down. Over billions of years, this could lead to tidal locking, changing the planet's climate forever. While this process is too slow to impact us directly, it serves as a reminder that Earth is constantly evolving, and the forces shaping our planet operate on timescales far beyond human lifetimes. Perhaps the most profound lesson is how fragile and unique our planet is. Earth's ability to support life depends on a delicate balance of rotation, gravity, magnetic shielding, and atmospheric composition. If just one of these factors were drastically altered, our world could become uninhabitable. This realization underscores the importance of protecting our planet, not just from natural disasters, but also from human-caused environmental changes that could disrupt this balance. Finally, this experiment makes us think about humanity's long-term survival. If Earth's conditions ever became too extreme, would we adapt, find a way to control planetary forces, or leave Earth altogether? While such challenges may seem distant, they force us to consider our role in the broader story of the universe, and how we might one day ensure the survival of life beyond our home planet. Earth won't stop spinning anytime soon, but by exploring this scenario, we gain a deeper appreciation for the forces that shape our world, and the responsibility we have to preserve it. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.